We reviewed how to complete exponents because we're going to be using exponents in prime factorization. Prime factorization is a process where we take a composite number and we break it down until we have it written as a series of factors that are prime numbers. We are going to be doing this by creating a factor tree. So for example, we're going to start with the number 24. 24 is a composite number because there are more than just two factors that can be multiplied together to create the product of 24. Yes, we can do 1 times 24, but we can also do 2 times 12, 3 times 8, 4 times 6, and that's about as far as I can go right now. But anyhow, that is how we create 24. So what we're going to do is we're going to break down the number 24, which is composite because it has more than two factors. And then we're going to break it down using a factor tree. This is how you do this. We start with the number at the top of the tree, and then the students will give me two factors, any two factors that they can think of. Let's suppose that they first thought of 6 times 4. You write those two numbers down. These two factors create 24. Now, what you do then is you look at the next level of the factor tree and you look at each factor individually. So for the factor 6, can 6 be broken down into two other factors? Is it a composite number? The answer is yes. 6 can be created by 1 times 6 or 2 times 3. And so we need to break down this number one more time. 2 times 3. 2 times 3 equals 6. So we've broken down this factor even further. Now let's go to the other factor, 4. 4 is also a composite number still, so we need to break it down even further. So what two factors could I use to break down the number 4? 4 can be created with 2 times 2. Now we look at the third level of our factor tree and we have to figure out if we have prime or composite numbers in this level. So, is 2 a prime or composite number? The answer is 2 is a prime number. The only two factors that create 2 are 1 times 2. Is 3 prime or composite? 3 is prime because the only two numbers that can create 3 are 1 times 3. And we already discussed that 2 is a prime number. So basically what you're doing is you're taking the composite number and you factor it. You break it down into two factors. You have to check those factors to see if they are also composite. In this example, 6 was still composite, and so you break down that number, 6, even further. And we broke it down right here with 2 times 3. Then we look at our other factor, and we realize that 4 is still composite, so we have to break it down even farther. We broke down 4 into 2 times 2. On our final level here, we've discovered that all of the numbers that we are left with are now prime numbers. Now we're finished. That's what prime factorization is. You take a composite number and you factor it down until what you have is a string of prime numbers that factor the number. Now, here's the tricky part. To write this answer using exponents, this is how we do this. First, I'm going to always start with the smaller number. So we have the number 2. But I've noticed that the number 2 is repeated. This is where we use our exponents. How many times is 2 multiplied right here in the answer? And the answer is 1, 2, 3 times. So what we really have here is 2 to the 3rd power. And just a quick review, that's true because this 2 to the 3rd power is the same as 2 times 2 times 2, which is what we also have here. So that works. Then we put the multiplication sign, and we write our other factor, which is a standalone factor, just 1, 3. So our final answer using exponents is 2 to the 3rd power times 3. So again, prime factorization is taking a composite number, and what you do is you do a factor tree, and you just take it level by level, and you break it down into factors. Here we took 24, we broke it down into two factors, 6 times 4. But then we had to look at that level of the factor tree and we realized that those two numbers are still composite. So what we had to do then is break down each of those factors. So 6 is broken down into 2 times 3, right here, and 4 is broken down into 2 times 2. So then we looked at our third level of the factor tree, and we looked at each number, and we realized that now we have all prime numbers. The final step was to write down any repeating factors as an exponent. So since 2 repeated 3 times, we wrote those factors as 2 to the 3rd power. And then we multiplied that by our standalone factor 3. And this is the final answer for the prime factorization of 24.